Woohoo! I'm having so much fun!
Hey kid, want to learn about nuclear fusion?
No, that sounds boring.
Don't be ridiculous. Nuclear fusion's a very exciting topic.
Really?
Of course, why would I lie to you?
Well, you are a stranger.
Oh, don't worry about it. Come along.
Okay. Whoa! Ow!
Get up!
That really hurt. Wait, isn't this the same place as before?
Of course not.
Yeah, it is.
No, it's not.
Yeah, that's the same window.
No.
Yeah.
No. Be quiet.
Oh, fine. So, what is nuclear fusion, Doc?
Well, nuclear fusion is a nuclear reaction in which light atomic nuclei collide and fuse, producing a heavier one in energy.
That's really cool.
It sure is.
So, how does it work?
Nuclear fusion is attained by heating deuterium and tritium, two isotopes of hydrogen, to be very high temperatures, creating a plasma. The nuclei are then able to fuse, creating helium and energy. According to the Coulomb Center for Fusion Energy, the temperature required is about 100 million degrees Celsius.
Holy cow!
That's hotter than the core of the sun.
Whoa! How do you contain something with such a high temperature?
Well, a type of magnetic containment unit called a tokamak is used to keep the plasma away from the machine walls.
Whoa. So, where's this used?
Well, currently there are no commercial applications for fusion energy, due to the difficulty in achieving a net gain in power. Fusion on Earth is mostly used in research, but it is what powers all the stars in the universe.
Whoa! That must mean it's pretty efficient.
Well, actually, scientists have run into problems getting more energy out of fusion than they put in. But ITER, an organization between countries to build a functional fusion reactor, has the goal of producing 500 megawatts of power with an input of 50, a gain factor of 10.
Whoa! That's awesome!
Well, on to the next level, social implications.
Okay.
Let's go.
Oh God, not this again. Ow! Wait, what the hell?
What?
What happened?
We're on the next level, social implications.
Yeah, but we fell up.
No, don't worry about it.
But doesn't that defy the laws of
Shut up!
Oh, okay. How much does it cost to make a power plant then?
Well, according to ITER, the cost of building their reactor is around $19.3 billion.
Holy crap!
This reactor is planned to produce 500 megawatts from an input of 50.
Whoa!
The largest cost is expected to be the superconducting magnets used in the containment unit. Second, the buildings housing the reactor. The cost of fuel will be less than 1% of the cost of electricity.
Wow.
According to Synapse Energy, a coal-fired plant is $3,500 per kilowatt. Therefore, a 500 megawatt plant would cost approximately $1.75 billion. This shows one downside of fusion energy: its high cost. Even though initial development is costly, fuel is very cheap. Deuterium can be distilled from any water. And according to Encyclopedia Britannica, 1 ton of deuterium has the energy equivalent of approximately 29 billion tons of coal.
Whoa! So, how expensive is it to maintain?
Well, it's hard to determine the maintenance costs of a commercial reactor due to its lack of existing.
How much does the research cost?
According to FocusFusion.org, since 1953, the United States has spent $22.4 billion on nuclear fusion research.
Whoa, that's a lot! So I guess the government has a large part in funding this type of energy.
It sure does. As well as what the U.S. has spent on research, ITER is fully funded by different governments. According to ITER.org, the European Union is contributing 34% to the project, Japan and the US 13%, and China, India, Korea, and Russia 10%.
Whoa! Is there any private funding in this sector?
There's definitely private funding in fusion. For example, Lockheed Martin is in the midst of research to build a compact fusion reactor.
Whoa, that's cool.
Sure is.
Does this type of energy have any effect on the people living around it?
The effect on location is primarily down to having large, ugly cooling towers visible from miles away. This could have an effect on property value.
Is it dangerous to one's health?
There are practically no dangers to people's health associated with nuclear fusion.
That's good.
Unlike fission, no hazardous wastes are produced, and since there is no chain reaction involved, the reaction can't get out of hand and cause an explosion.
So, nuclear fusion seems to be much more beneficial than other forms of energy.
Yes, though it is initially expensive, the long-run benefits outweigh the cost, such as the lack of unhealthy pollutants and the high energy-to-mass ratio of the fuel.
Yeah, cool.
Well, now on to the next level, environmental implications.
Oh no. Ow! That really hurt! Ow! My leg! Ow!
Get up!
Oh, okay. So, are there any environmental costs to using this type of energy?
The environmental costs to fusion are very low. According to the Cullum Center for Fusion Energy, a 1500 megawatt plant would produce around 1 kilogram of helium per day, so helium pollution isn't a problem.
That's good.
Also, helium isn't even a greenhouse gas, so it wouldn't contribute to global warming. The only potential cost of this form of energy would be if the tritium fuel was produced in a fission reactor, producing hazardous waste. This can be eliminated, though, by breeding tritium in the fusion reactor itself using lithium.
Cool.
Yeah.
So, it's mostly beneficial in terms of the environment.
Well, fusion would benefit the environment by replacing other harmful energy sources. For example, the atmospheric pollution due to fusion is far lesser than the atmospheric pollution due to other methods of energy production. According to the Cullum Center for Fusion Energy, 1 liter of water contains enough deuterium to produce the same amount of energy as 500 liters of gasoline.
Whoa!
This would cut down pollution from cars if the electricity was used to power electric cars. Also, 10 million times less helium would be produced from fusion than CO2 from fossil fuels in producing the same amount of energy.
Whoa!
So, due to extremely low emissions of a fusion plant, the benefits heavily outweigh the costs.
That's good.
So there you go, Sonny. Now you know all about fusion.
Yeah. That was 10 minutes of my life I'm never getting back.
Oh, shut up!
Well, that's all, folks.